Hey guys, welcome to Easy Measy Science channel. This is Sofan Al-Fallata. I hope you are doing great as you are watching this video. In today's video, I will explain a principle that was formulated by a Greek physicist and a mathematician of Syracuse. That is the Archimedes Principle, which is a basic law of physics and fundamental to fluid mechanics. So don't forget to hit the like and subscribe button if you want to be the first person to know when we upload anything new. So let's start. So, the Archimedes principle states that any object completely or partially immersed in water or fluid experiences an upward or a buoyant force equal to the weight of fluid it displaces. So, in order to understand this concept, we need to know what is meant by the term buoyancy. So, buoyancy is simply the tendency of a body to float or to rise when submerged in a fluid, that is, when a body is placed in a fluid. So the tendency of this body to float on the surface of the fluid is what is known as buoyancy. So from the condition of floating, the buoyant force Fb must be equals to the weight of the fluid displaced, where the subscript represent fluid. So this we will have mf multiplied by g, where this is the mass of the fluid and this is the acceleration due to gravity. And also we know that from the equation of density, that is density is equals to mass over volume, we can write the buoyant force as Fb is equals to rho f Vf multiplied by g. So let's name this as equation 1, and this is the equation for the buoyant force, and it's equals to the product of the density, volume, and acceleration due to gravity. So also from the Archimedes principle, it is known that the weight of object must be equals to the weight of fluid displaced. Okay, so from Newton's third law of motion, we can write that MOG must be equals to MFG, where MO is mass of the object and here MF is the mass of fluid, and this acceleration due to gravity cancels out. And writing the mass in terms of density and volume, we will have rho naught V naught is equals to rho F Vf, that is from the equation of density is equals to mass divided by volume. So when making the mass as subject of the formula, we will have this. So let's name this equation 2. So from this we can get the ratio of the densities. The density of the object to that of the fluid will be equals to the volume of the fluid divided by the volume of object, and this is our equation 3, and it is known as the submersion, the fraction of the submerged object. Also from equation 1, which says that the buoyant force is equals to rho F Vf G. This is the first equation we derived. From the Archimedes principle, the volume of fluid displaced must be equals to the volume of object. That is, if the object floats. However, Vf displaced is equals to V naught. So, replacing Vf by V naught in the first equation, the buoyant force will be equals to rho F V object multiplied by G. So this will be our equation number 4. Here we are trying to derive an expression whereby we can determine if the object that is immersed in water will float or will sink into the water. So from the previous diagram, we can see that when the object is submerged in water, there will be a weight acting downward, that is the weight of the object, and also the buoyant force will be acting upward. So the net force upward on the object can be written as will be equals to, that is the buoyant force that is acting upward, and then minus the weight of the object which is acting downward. So this net force, that is F subscript n, will be Fb minus m naught G. Okay, so from here we can write Fb from equation 4 is rho F V naught G minus m naught, that is rho naught V naught, expressing the mass in terms of the product of the density and volume of the object multiplied by the acceleration due to gravity. So when we factorize the like terms, the net force will be equals to rho F minus rho naught multiplied by V naught G. So this is our equation number 5, and it represents the net force upward on the object. So there are two conditions, two cases, that is, if the density of fluid is greater than the density of object, then this force will have a positive value. So the object floats. And if the density of fluid is less than the density of object, then the net force upward on the object will be negative, and then the object sinks into the water. So these are the two cases. It's either that the object floats on the surface when the net upward force is positive and sinks when the net upward force is negative. Also, we can write the fraction of the submerged object in terms of the weight. So, based on the Archimedes principle, when the object is placed in a water, it loses weight, and the weight of the fluid displaced by the object will be equals to the true weight minus apparent weight. So that implies that the actual weight of an object is greater than the weight of the same object when immersed in water, and also the volume of the displaced fluid is directly proportional to the weight of the fluid if the surrounding fluid is of uniform density. So the weight of the fluid displaced is directly proportional to the volume of the fluid displaced if the surrounding fluid is of uniform density. And so from this condition, we can also derive a fraction of the submerged object in terms of the weight of the object instead of the volume. So the fraction of the densities of the fluid and object can be written the density of object divided by the density of fluid displaced is equals to the weight divided by weight of fluid displaced. So writing the weight of fluid displaced in terms of the true weight and the apparent weight yields this expression. So, by the virtue of this equation, the ratio of the densities of object to that of fluid can be determined without having the volume of the object and fluid.
Okay, so that's it for today's video. I hope you guys enjoyed it. If you did, hit the like and subscribe button, and don't forget to share with your friends. And if you have ideas about future videos, you can drop a comment below and we'll try our best to make that video for you. Thank you for watching and have a nice day.